We'll take a quick look here at objective 3.3, which is describe how the routing table is populated by different routing information sources. We're going to talk about administrative distance again here for a minute. And then compare and contrast static routing and dynamic routing. The other ones are configure, troubleshoot, which I want to try to do with demos so that we can see how they actually work. It's configure and troubleshoot inter VLAN routing, router on a stick, configure, verify, troubleshoot IPv4 static routing, and then configure and troubleshoot RIP v2 for IPv4, excluding a whole bunch of stuff. So it's a basic configuration for ICND1. But anyhow, the protocols, how do we populate the route table, and static versus dynamic routes or routing protocols. Of course, static doesn't have a routing protocol, it's just a route. So to populate the route table, dynamic versus static here, the protocols each have a process, and then we talked about the administrative distance, and the administrative distance, as you remember, was how trusted is the route. So if we're using static routes, they're going to be the most trusted unless we change the administrative distance of that route, and that's when we get into some of these configure when we talk about a floating static. A floating static is going to be one that backs up a dynamic in case something happens to it. So since the statics have an administrative distance of 1, if you'll recall, it's going to override any sort of a dynamic route. So we're going to use the administrative distance to determine which protocol goes into the route table. If we have a RIP and an OSPF advertising the same routes, then the OSPF is going to be the one that shows up in the route table. To demonstrate that, did a little demo here. I'm kind of one of those dense people that I really need to see things a lot of times. So what I've got is all of these guys are connected on an Ethernet to a switch here on the 192.168.1 network, just to simplify it. And we have on the back side the 192.168.10, 20, and 30. To demonstrate that one supersedes the other, I've configured OSPF and RIP on these two routers and only RIP on this router. So if we'll go to the only RIP one here, let me get it over here, get my junk off. If I go into it and show IP route, then it has RIP routes going to the 10 and the 20, and then the 30 network is directly connected to it. And if we can do a show run, I know that this is the way to get some of the commands in to look at too. Show run router RIP is the only protocol, and if I show IP protocols, then it tells me sending updates. Routing protocol is RIP, sending updates every 30 seconds. RIP is, and we're going to look at it, it's going to be a distance vector protocol. It's a broadcast protocol, sends update every 30 seconds, which is kind of worrisome to the network, I guess. A number of things, routing for networks 192.168.1 and 30. So it's sending those things. There aren't any passive interfaces, and passive interfaces are the ones that tell us to not play with that particular interface. The distance here is the administrative distance. Default is 120, and 120 is the administrative distance for RIP. So if we go to one of these other routers here, and we'll do it, show IP, you can see it's there, show IP route, we have OSPF 192 for the 20 network and RIP for the 30 network, and RIP was the only protocol that was on the 30 network. And if we show IP protocols, we say IP protocols is RIP every 30 seconds, redistributing RIP, default, automatic summarization, routing for networks 1 and 10. Passive interfaces default is 120. So we have a distance here of 120. If we go on down a little bit farther, routing protocol is OSPF, and 2 is the process ID. It's just something that's locally significant so it can keep up with it. Maximum paths for routing for 192.168.1 and 192.168.10, and its distance is 110. The default is 110, and that is the administrative distance for OSPF. So we have both of these operating, sending information about 1 and 10, but when we get to the router that has both of the protocols enabled, only the OSPF shows in the route table, although RIP is available there, so that we have the capability to have more than one routing protocol running on each of these, and it uses the administrative distance to determine which one. Now a little bit about static and dynamic. Static routes are the ones where we manually configure the route table. The static routes allowed for fixed routing paths in the network, and you only want to use static routes in a small network. When there's a change in the network, we've got to go back and change the route tables. Private routes, except when they're redistributed. And redistributed is when I tell it a protocol to advertise. What this means is that static routes do not get promulgated to other routers unless we take a specific action called redistribution and tell the OSPF, for instance, to redistribute static, to redistribute those routes, to advertise them to the other network. Use less bandwidth. They use no bandwidth because we're not sending any information out, and RIP, if you recall, was every 30 seconds was doing that. So it takes fewer CPU cycles, and static routes are used in environments where the network traffic is predictable, the network design is simple, and it's a small network. Probably would work with this one, and we'll go through. An IP route is the command that we use in order to do that. Even on one like this, if we were using statics, we would have to say IP route 192.168.30 and then where we're going, the next hop address here. And then we would have to do IP route 192.168.20 and use this as the next hop address. Once we've done that, then we have to go to each of these routers and give it a path back, because if it gets there, it's not going to remember how it got there. We got to tell it how to get back. So then we would have to go here and use an IP route 192.168.10.0, 255.255.255.0, 192.168.1.1, the next hop address, to send it back in this direction. Same thing here. So for each of the networks that we're going to get to, we have to have a route table, a routing entry, an IP route command to get to that route as well as to get back from that route. So yes, they are simple networks, no overhead, but you really don't want to use them unless it is a relatively small network. And then here is the command IP route 10.12.0.0.255.255.0.0, 10.11.1.1. This is to get to this network over here when we do those things. The dynamic routing protocol classes. 3 classes. First one's distance vector. Is used to find the best path to a remote network by judging its distance. RIP is a distance vector protocol. RIP routing, each instance where a packet goes through a router is called a hop, and the route with the least number of hops to the network will be chosen as the best one. And this truly is the fewest number of hops, which is kind of a killer. So if we had something like this, and let's say this is a 256K. Actually, let's just go, I messed that up. Let's just go here and make that go away. A 256K going from there, and then we have a maybe a gigabit connection here, and this is a 1 gig connection, 2 hops, put a router in here, 2 hops. It's going to take the 256K because it's going to take the least number of hops. Doesn't care about the speed. Will be chosen as the best one. The vector indicates the direction to the remote network. It's a distance vector protocol. Periodically sends out the entire routing table, and the periodic, as we saw a little earlier in the demo, is every 30 seconds to directly connect to neighbors. So tell a friend who tells a friend who tells a friend, and that's the way that the route table gets built. Link state, also called the shortest path first. The routers create 3 separate tables. One keeps track of the directly attached neighbors, the neighbor table. One determines the topology table of the entire network, and one is used as the routing table. IP routing protocol is completely link state. Send updates containing the state of their own links to all directly connected neighbors. And again, tell a friend who tells a friend who tells a friend, then propagate it to their neighbors, so that eventually we learn the entire topology. The third one's a hybrid protocol. So this one is RIP in the protocols that we're going to do. This one is OSPF. Then this one is EIGRP. Distance vector contain the aspects of both, and EIGRP is a great example. Cisco typically calls it an advanced distance vector routing protocol, so you may see it called either that. It is typically going to be the one that we call a hybrid protocol. So dynamic routing won't be able to use static routes in a large, constantly changing networks, because the static routes can't react to network changes. So if you're going to have changes, yes, you want to definitely use dynamic protocols. Most networks use the dynamic routing protocols. The OSPF and EIGRP really don't take that much bandwidth. Another limitation of RIP is that it can only go 15 hops. 16 is infinity. So it is limited in size as to how far that it can go. Changes in the dynamic routes are shared with the router. Something changes, we don't have to go back in and change everything in the world. Use IP routing protocols such as RIP, and this was what was in the slides, but such as RIP, and I would say such as EIGRP and OSPF, to learn the routes dynamically. You can configure either of these routing protocols on your router, and we looked at that and saw that the one with the best administrative distance is the one that actually gets displayed in the route table and is used. So what we talked about here, we populate using the administrative distance. Each of the routing protocols has its own method of sharing the route information. The one that gets displayed is the one with the best administrative distance. Static routes can be used in simple, small networks. They are secure. They're not shared. They are only on that router. And again, we want the network to be relatively small if we're going to use static routes. The dynamic routing protocols, we had the distance vector, RIP, link state, which is OSPF, and hybrid, which was EIGRP. I want to try to do some demos for the next few, I think 3 objectives, so that we can get a look at how to do some of the configurations as well as to see what happens with them. So what we're going to do next is configure a router on a stick.